All right, good morning, guys. Today we're getting into 8.6b, which is where you all have to know how to differentiate, or in other words, tell the difference between speed, velocity, and acceleration, and also calculate um, those things. So, very similar to how we were calculating force is equal to mass times acceleration last week. Um, this week we'll be looking at some speed calculations as well. All right, so first of all, let's understand what speed is. Now, speed is something that you all see all the time in your parents' cars. They have um, they've got the dial that's on the car called a speedometer that tells what their constant or what their current speed is. When you look on the road, you see signs all the time that tell you what the speed limit is. So we're fairly familiar with the term speed and how it's applied in our daily lives. But by definition, speed is the distance an object travels in a given amount of time. So if it takes 1 hour to travel 50 miles, then the average speed that that car was driving was 50 miles per hour. So for every hour, it's going 50 miles. Okay. Now, nowadays with phones and GPS and stuff like that, we don't necessarily have to map out things, and the maps, Google Maps, will tell you exactly how long it's going to take you to get from point A to point B. Back in the old days when I was growing up, we didn't have that kind of stuff, so we had to use maps and determine how many miles it was between where we were and where we were going, and then kind of do some calculations, some math calculations about what the average speed that we could travel is based on speed limits of different roads, because the road outside here in front of school has a speed limit of 35 miles per hour, sometimes 20 during school zone times. But when you get up onto the highway, the speed limits can be upwards of 65 or 75 miles per hour. So when we were trying to calculate our trip, we would have to look at the distance between where we were and where we were going, calculate what the normal speed was that we could travel, and then that would give us an estimated time as to how long it would take us to do that. So I remember sitting at the kitchen table with my father, actually having to do those math calculations. Now, of course, in 2020, we have all this technology that does all that stuff for you. But still important to understand that speed is how far you can go in a certain amount of time. So if you're traveling at 50 miles per hour and you travel for 2 hours, then you can go 100 miles in 2 hours. So how you change your speed determines how long it will take you to get from point A to point B. So what is the formula for speed? Speed is distance, how far you've traveled, divided by the time, how long it takes you to travel that distance, and that will give you your speed. And so when we are calculating it, we can use a triangle just like we used last week with force equals mass times acceleration. And again, how we use this triangle is if the question is asking you for speed, we cover up the S and its distance divided by time. If we're looking for the distance, given the speed and the time, it's speed times time. And if we're looking for time, then it is distance divided by speed. So you'll need to be familiar with how to manipulate that formula. The unit for speed is meters per second or kilometers per hour. Those are the SI or scientific units that we use in science. However, in our daily lives here in America, we measure things in the old English system. So you'll more commonly hear speed units referred to as miles per hour, or maybe even sometimes feet per second. But in science, we're always going to either use meters per second or we'll use kilometers per hour. Okay. All right. So that's speed. Now, notice that everything we talked about speed wise, I never said what direction you were traveling. So speed is what we call a scalar quantity. All it has is a magnitude, a number. However, sometimes it's important to understand, in physics especially, the distance or the direction that something travels. And so when we add a direction to it, we add something called a vector. And a vector is just simply a direction. It could be an arrow, it could be to the right, it could be north or south. So when we add a vector or a directional component to speed, it is no longer considered speed. Now it's called velocity. Okay. So, excuse me. So you might say that the car is traveling at 50 kilometers per hour to the north. And again, vectors can be used to show the direction of an object's motion. So if we look at this page right here, it says which of these shows speed and which shows velocity. So the easy thing to remember is anytime there is a direction, then that's going to be velocity. Anytime there is not a direction, then that's going to be speed. So if we look at 67 meters per second N is referring to north. So that means that this would be a velocity. Okay. 25 meters per second, there is no direction. So that means this would be a speed. 90 kilometers per second up. So that's also a direction. So that's going to be a velocity as well. And then the last one here, 13 kilometers per second, there is no direction. So that means this one would be speed. Okay. All right. And so the last thing here is understanding what acceleration is. Now, again, here you see this speedometer that's normally on a car. And I do want you to notice that this is not a speedometer that we would see in the United States. And the reason for that is if you look on the big numbers here in white, that is measuring speed in kilometers per hour. The little numbers on the inside are measuring it in miles per hour. And that's important. So in America, these numbers would be flipped. So we would have miles per hour on the outside, the bigger numbers, because that's how we measure speed. And that's the speed limit signs here in America are in miles per hour. But if you go into any other country, even the two countries that border us, down into Mexico or even up in Canada, the speed limit signs there are in kilometers per hour. So they go ahead and put both on cars. Depending on where that car is being driven, you can use either one. And so you can notice the difference here that 60 miles per hour here in orange is actually equivalent to almost 100 kilometers per hour. So a couple years ago, I drove into Canada. And of course, being a science teacher, I knew this was going to happen. But for people that may not be paying attention, when you drive over the border into Canada and you see a speed limit sign that says 100 kilometers per hour, you need to remember that that's in kilometers per hour, not in miles per hour. Okay. So they go ahead and put both sets of those numbers on most cars so that depending on what country you're driving in, you can see how fast you're going in both miles and kilometers per hour. Again, America, the only country on the planet that still uses miles per hour or the old English system to measure distance. So what is acceleration? Now, we talked a little bit about this last week because A in the force equals mass times acceleration is acceleration. So when a force is applied to a moving object or to a stationary object, that object can either speed up, slow down, come to a stop, or change direction. All of those things are a form of acceleration. It doesn't just have to be about speed. It could just be about changing direction. So acceleration is any change in motion. Any change in motion. Okay? Speeding up would be positive acceleration. Slowing down would be negative acceleration. Coming to a stop or changing direction also forms of acceleration. So the velocity is really what we're talking about here, because remember, acceleration is a change in speed or direction. So ultimately, we're talking about a change in velocity, because velocity can change either by changing the scalar portion of it, the number portion of it, or velocity can change by changing the vector, whether it's going north or south, east or west, up or down, left or right. Okay. So if I said I'm going 20 miles per hour to the north, and then I turned and went 25 miles per hour south, then that's acceleration. My speed didn't change, but my direction changed. So if my direction changes, my velocity changes. Therefore, I have accelerated. Okay? So the change in velocity is called an acceleration. So how do we calculate acceleration? Acceleration is calculated by looking at the change in velocity over time. Okay? So what that means is very similar to your formula that you're using in math, slope. Okay, you're looking for the rise over the run, and so one of the formulas that you might have to use during slope is y2 minus y1. That's the change in y over x2 minus x1, which is the change in x. So here for acceleration, we're looking for a change in velocity. So if a car was traveling at 50 miles per hour and sped up to 70 miles per hour, the change in velocity is only 20 miles per hour, right? Because it started at 50 and got to 70. So we're only looking at the change in the velocity, all right? And then how long did it take that velocity to change? So if the change in velocity was 20 meters per second and it took you 2 seconds to do that, then your acceleration would be 10 meters per second per second. And I know that sounds weird, but what that means is for every second you traveled, your speed increased by 10 meters per second. So that's why we say 10 meters per second per second. Okay? All right. So that's how we calculate acceleration, and we'll get to calculating acceleration a little bit later on in the week. So an object falling to Earth is subject to a change in acceleration of 9.8 meters per second squared due to gravity. So again, what that means is for every second that you fall, your speed or velocity will increase by 9.8 meters per second. So after 1 second, you'd be traveling 9.8 meters per second. After 2 seconds, you'd be traveling 19.6 meters per second. And you would increase your speed every second by 9.8 meters per second. So the longer you fall, the faster you will travel. Okay? So some examples of acceleration are stepping on the brakes or slowing down, or pedaling your bicycle faster or speeding up, or any change in direction. Okay, so acceleration can be a change in speed or a change in direction. All right, guys, hopefully this answers some questions and gives you a good jumping off point for understanding the differences between speed, velocity, and acceleration.